Mike Tyson's 9 boxing glove by himself. That's Rob Scott. They look like boys in Thai boxing. Mike tosses Buck Scott. Oh, Buck Scott.
Okay, before we go to your notes, I just want to make sure that everybody's under the same understanding. We've been graphing things that look like this, right? So I just want to use a cubic, for example, for a second. This crosses the x-axis how many times? 3. So if you see x is third, you expect to see it cross 3 times. We're kind of putting the cart in front of the horse on this one because we really get to this on Monday. Monday, I think, is the coolest lesson of the entire semester, in my opinion. But here we're going to draw an x cubed as well.
But it's not going to cross 3 times, is it?
Right, because we say that it has 1 real solution and it has 2 imaginary solutions. So that's the whole idea, is that we want to say that there's 3, but we can't unless we recognize that there are these things called imaginary solutions. Now, before I get there, does everybody agree it's impossible to draw a cubic that doesn't cross at least once? It's got to cross once for sure. Okay, and so so we can see that if it does have imaginary solutions, it's going to be 2 of them. Now, here's part of the neat thing that comes up in this situation is when the mathematicians put forth this kind of ridiculous idea of imaginary numbers, their motivation was this. It was, we'd like to say that there's 3 solutions, but the only way we can is if we say that there's 2 that are imaginary. And so they in their notes, they're like, so now we have this idea of an imaginary solution. Sounds silly. We don't see any practical application for this at all. What good will ever come of this other than that? Well, they didn't know. Does anybody know whether this smart board right now, or this new line board, does anybody know, is that alternating current electricity or direct current?
Alternating.
That's alternating current. Whereas, does anybody know, is this alternating current or direct current?
Direct
current. Direct current is when you're pulling power from a battery. Alternating current is through this wiring system here. That's a big deal, because if you did not have alternating current, you would have to have a power station, direct current, on every single block of the entire city. You agree that that's a lot more infrastructure, a lot more demand, a lot more cost? The only reason why alternating current is possible at all is through the study of imaginary numbers. Okay, that's it. And so what we've learned over years, time and time again, is that math, a lot of times, is hundreds of years ahead of us. So whatever is being worked on in math right now, you're not going to see the applicability now. It's going to be in a few hundred years before we see that. So let's look at our imaginary numbers in our review. I think that you've seen this before. The square root of -1 is I. And I squared is -1. So those mean the same thing. The square root of -1 is I, and I times I is -1. Our goal today is to be able to write complex numbers in standard form. This is a complex number that has a real part, and then the BI is the imaginary part. Okay? So we have real numbers, we have imaginary numbers, and then we have complex numbers where they're combined together. We want to be able to add them, subtract them, multiply them, divide them. 4 plus 3i is an imaginary or complex number. 6 minus 8i is a complex number. We will subtract them. And so it's 4 plus 3i, and it's a minus 6, and it's a plus 8i. And all you do is just combine like terms. Our real terms will be -2, and our imaginary terms will be positive 11i. Can you get that problem on the test? Yeah. The next one is 1 minus I plus 3 minus I minus 6 plus 5i. Again, make sure you distribute your subtraction. We combine our real parts together. 1, 3, and -6 make -2. -i, and 5i make 3i.
Sick.
Let's multiply them. 4i times 7i is 28i squared. And what is I squared?
Negative. So
negative 1. So 28 times negative 1 will be negative 28. Try the next 4 problems on your own. The next 4.
Should be 18. Negative 18.
What?
Negative 6i times negative 2i.
It's 12. 6 times 2 is 12.
Okay, sorry.
She said negative 12 on that?
Okay, let's see what you got. I have a negative 24I squared. I squared is negative 1, so this is a positive 24.
That would just be a negative 12.
You got IQ.
Oh. Then we have a positive 2I squared. I squared is negative 1, so this is negative 2. The negatives cancel. I get a 12I cubed. I'm going to write it as 12I squared times I. Notice I squared makes it negative, so it's a negative 12I.
Dang.
Here we're not cubing the negative, we're just cubing the I, so I have a negative I squared times I. I squared is negative 1 times a negative is positive 1.
So it's just I.
So therefore it is just I.
So I'm going to say it's negative 1.
So the next one?
Yeah.
What do you guys think? I know the 122nd power.
I'm going to say negative 1.
Why?
Because it ends on 2. Because 122 ends on a 2.
I to the 12th, that'll be I squared times 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 I squared, right? Negative 1 times negative 1 is 1. Negative 1, 1, negative 1, 1. So if it's the 12th, it's 1.
So then it's 1.
But that's not.
No.
It's negative 1.
The important piece here is that we write it in terms of I squared. I squared is our key. So I have I squared to the 61st power. Does everybody agree that 122 divided by 2 is 61? Now I made the problem easy because I squared is negative 1. And what if you take negative 1 to an odd power? It stays negative. So if it's I to the 124th, then it would be positive 1. Flip it on over.
Oh. Hey.
Wait, what is the answer?
Negative 1.
I'm going to distribute my 3i to each term, and I get a 6i minus a 15i squared. What's going to happen to the minus 15i squared?
It would become a positive 15.
It would become a positive 15 plus 6i.
Why?
So we got I squared is negative 1, right? The next one, we have 2 minus I times 2 plus I. Do you notice that those are conjugates? They're the same, except the ending changes from positive to negative. When we multiply conjugates, what happens to the middle? They cancel. And so I get 4 plus 2i minus 2i minus I squared. The middles, gone. So I have 4. What's going to happen to the negative I squared? Positive 1, so you get 5 out of that.
Okay.
Try the next one on your own. Try the next one here. It's 6 plus I times 3 minus 7i.
No.
I could see the negative 7i squared is going to turn into positive 7, plus the 18 is 25. And then negative 42i and 3i is going to make negative 39i.
Dang. A finger.
We've added, subtracted, multiplied, now we divide. I can't leave 4 over I as an answer. It must be written in the form of a plus bi. So the I must be in the numerator. Any ideas what we do?
Multiply the top and bottom by the
You are correct, not the reciprocal, but we simply just multiply top and bottom by I. Because I over I is 1. That will not change the value of the fraction. We get a 4i in the top, and I times I is negative 1. And so you get 4i over negative 1. That will change it from a positive 4i to a negative 4i. And that's your result. For the next one, some people multiply top and bottom by 2i. You don't need to multiply by 2i, just multiply by I. I don't care if there's a 2 in the denominator. I care that there's an I in the denominator. And I get a negative 3i squared, a negative 3i in the top. And the bottom I get a 2i squared. The I squared becomes negative, which will cancel the negative in the top, and so I have 3i over 2. And just to be clear, so everybody knows, this is the same as 3 over 2i. Those are equivalent, whether you put the I in the top or off to the side. Just you can't have it in the bottom.
What happened to the negative?
I squared is negative 1, and so the negatives cancel.
Oh, okay.
Talk to the person next to you. What do you think you should do for the next one? Try something. Talk about it. What do you think we should do?
Times the top and bottom by 5 plus 1. So then you get I plus 1 squared.
Anybody want to talk about their option?
Multiply the top and bottom by I plus 1.
Close.
I minus 1.
I minus 1, the conjugate. Notice we showed you that example before. I actually referenced the conjugate. That way we make the middles go away. If you notice the top when we multiply, we got 5. All the imaginary parts went away. Thus the conjugate is the option. If I multiply the top, I have a 3i minus 3. In the bottom, I have I plus 1 times I minus 1. As I multiply them, I times I is I squared, or negative 1. The middles go away, and then 1 times negative 1 is also negative 1. And so we have a negative 3 plus 3i all over negative 2. So I just wrote the 3 first and the 3i second. You can leave it like that. I'll give you credit on the test. But to truly put it in the form of a plus bi, it should really be written as 3 over 2 minus 3 over 2i. Technically, that's the form that they are looking for in the book and ACT and things like that, but I'd accept that if you had it. Question, Keith? Wondering how I went from here to here?
Yeah.
I just divided each one by -2.
Okay.
So -3 over -2 is 3/2, and that one by.
Okay, that makes sense.
See if you can do this one by multiplying by the conjugate, okay? You know the step, multiply by the conjugate, see if you can come up with the right result. Either one of those would be accurate, 8 minus 9i over 29, or 8/29 minus 9/29i. Did I do it right?
Is it okay if you have the negative 9 equals 8?
Sure.
You have to do like that.
Yep, that's fine. Okay, our last two examples for the day, the square roots. So, the first time I did this kind of a problem, I got it wrong. I took the square root of -2 times square root of -50, and I got the square root of 100, which was 10. Everybody think that that looks reasonable?
Yeah.
It turned out I was wrong. I didn't understand why, and then I just did a little bit of research because I never saw a problem like that when I was in high school. My teacher never addressed it for me, but I'll write this out just once. The square root of -2 is the same thing as the square root of -1 times the square root of 2. And the square root of -1 is I, so this reduces to I roots of 2. Agreed? So it turns out that when you have a square root, you need to expose the imaginary part right away. Similarly, this would be times I roots of 50. Now I can multiply them together. And notice that I get I times I, which is I squared, times the square root of 100. What is I squared?
-1.
What's the square root of 100? So you don't get 10, you get -10.
Okay.
For the next one, I will first write it with these square roots exposed. 1 plus I roots of 3, and 2 minus I roots of 5. I will distribute 2, negative I roots of 5, 2 I roots of 3, negative I squared roots of 15. I squared is -1. That's going to switch the negative to a positive. So this will become just the positive root of 15. So I have 2 plus the root of 15. And then my imaginary terms are 2I roots of 3 and negative I roots of 5. And to put this in the true form of a plus bi, we're just going to factor that I out. So we have 2 plus the root of 15, and then I times 2 roots of 3 minus the root of 5. And so this is now truly of the form a plus bi, because you have your a, you have your b, and you have your I. That's what they want. There we go. Good job making it through a